Welcome to Metaments Academy. In the previous video, we have covered some topics and important formulae, right? And in this video, we are going to learn some problems, how to solve some problems based on Fourier series concept. Let us take the first problem. Find the Fourier series for fx equal to e power minus ax in the interval 0, 2 pi. So, what is the Fourier series expansion of fx? The formula is fx equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Right. So, what is the function here? Given is fx equal to e power minus ax. The interval is 0, 2 pi. Right. So here we need to find out the values of a naught, an and bn. So here what is a naught? By formula it is 1 by pi integral alpha to alpha plus 2 pi f of x dx is the formula. Right. Here what is the interval? Interval alpha comma alpha plus 2 pi is given as 0, 2 pi. Therefore, 1 by pi integral 0, 2 pi, 0 to 2 pi, f of x is e power minus ax dx. So, what is the integral of e power ax? E power ax by a. E power ax by a. So, from that, you can write this as e power minus ax by minus a, because in the place of a we have minus a here. So integration is e power minus ax by minus a in between 0 to pi, 0 to 2 pi. So you substitute x equal to 2 pi in that. I can take minus a, it's a constant, I can take it out. So minus 1 by pi a into, when you put x equal to 2 pi, you will get e power minus 2a pi. Minus, when you put lower limit 0 in place of x, you will get e power 0. So minus 1 by pi a into e power minus 2a pi minus 1. You multiply this by this minus, what happens? 1 minus e power minus 2a pi by pi a. So this is a naught. This is a naught. Now let us find an. What is the formula of an? It is 1 by pi integral alpha to alpha plus 2 pi f of x into cos nx dx. It is 1 by pi integral alpha to alpha plus 2 pi is 0 to 2 pi. F of x is given as e power minus ax into cos nx dx. So in the first video on Fourier series, we learned some concepts and basic important formulae. In that there is a formula integral e power ax cos bx dx. The formula is e power ax by a square plus b square into a cos bx minus plus b sin bx. Right. So I told you this formula is we are going to use it extensively many number of times. Right. Now you compare this integral with this integral. In place of e power ax, you have e power minus ax. In place of cos bx, you have cos nx. So in place of a, we have minus a. In place of b, we have n. So you substitute minus a in place of a, n in place of b in this formula. What you will get? 1 by pi into e power minus ax by minus a whole square plus n square into a cos bx, a is minus a here, right? A minus a cos nx plus b sin bx. What is b? Is n. N sin nx. In between 0 to 2 pi. X equal to 0 to 2 pi. Now here my a square plus n square is independent of x. You can take it out. 1 by pi into a square plus n square into, because we are substituting x equal to 2 pi and 0. In this you have no x, so you can take it out. You put x equal to 2 pi in this, what you will get? E power minus 2a pi. In place of x we are substituting 2 pi. And minus a cos, put x equal to 2 pi, it's 2n pi. Plus n sin 2n pi. So this is when x equal to 2 pi minus lower limit. Now you substitute lower limit in this. What you will get? In place of x, you put the x equal to 0. It is e power 0 by nothing. It is already taken out, right? It is e power 0 into minus a cos 0 plus n sin 0, right? So it is 1 by pi into a square plus n square into e power minus 2a pi. So we already discussed this kind of formula. Whenever you see 2 pi or 2n pi, you can replace it by 0. So wherever you see 2n pi or 2 pi, 2 pi, 4 pi, 6 pi, 2 pi multiples, you can replace it by 0, right? So it is like cos 0 only. Cos 0 is 1. This is sin 0 is 0. Minus 1 into minus a. This is again cos 0 is 1. Sin 0 is 0. So this is equal to 1 by pi into a square plus n square into e power minus 2a pi into minus a. This is minus into minus plus a. Take a common. What you will get? A into 1 minus e power minus 2a pi by pi into a square plus n square. This is an. This is an, where n is running from 1, 2, 3 and so on. Don't forget to write this n equal to 1, 2, 3 and so on, because you are finding an, right? Now let us start finding bn. So what is the formula of bn? 1 by pi integral of alpha to alpha plus 2 pi f of x sin nx dx. 1 by pi integral alpha to alpha plus 2 pi is 0 to 2 pi. Fx is e power minus ax sin nx dx. So what is the formula of integral e power ax sin bx dx? This also we discussed in the first video in the concepts and basic important formula. If you have not seen, you can go and view that. You have a lot of important formula in that. Here it is e power ax by a square plus b square into a sin bx minus b cos bx. The difference is when you will get minus when it is sin. You will get plus when it is cos here. So this is 1 by pi e power minus ax, because in place of a we have minus a here, by minus a whole square plus n square, because b is n here, into a sin bx. A is minus a, sin bx is nx, minus b cos bx. Here b is n, right? In between 0 to 2 pi, x equal to 0 to 2 pi. So when you substitute x equal to 2 pi upper limit Now you take this a square plus n square out, put x equal to 2 pi, it is e power minus 2a pi into minus a sin 2n pi minus n cos 2n pi minus, when you put x equal to 0, e power 0 is 1, this is already taken out, into, you put x equal to 0 in this, minus a sin 0 minus n cos 0, right? Now, this is 1 by pi into a square plus n square into e power minus 2a pi into sin 2n pi. I have already told you, right, while finding an, wherever you have 2n pi, 2 pi multiple, 2 pi into integer multiple, you can replace it by 0, right? So it's like sin 0 minus n into cos 0 is 1 minus 1 into, this is 0 minus n. So it is 1 by pi into a square plus n square into e power minus 2a pi into minus n, minus in minus plus n. So it is n into 1 minus e power minus 2a pi by pi into a square plus n square. This is Bn. And don't forget to write n equal to 1, 2, 3 and so on. Right? So this is the value of Bn. Now let us write the final answer. It is fx equal to a naught by 2. What is a naught? A naught is already obtained as 1 minus e power minus 2a pi by pi a. A naught by 2. So you will get 2 pi a plus summation n equal to 1 to infinity. What is a n? A into 1 minus e power minus 2a pi by pi into a square plus n square into cos nx plus summation n equal to 1 to infinity. Bn, what is Bn? 1 minus e power minus 2a pi by pi into a square plus n square into n into sin nx, right? And you can leave it here, otherwise you can simplify this. What is f of x? F of x is e power minus ax. Therefore, e power minus ax Fourier series is, you can take 1 minus e power minus 2 pi a common, and what you will get 1 by, and you can also take pi in the denominator. You have pi in the denominator, you can also take pi out. So it is 1 by 2a plus summation n equal to 1 to infinity a by a square plus n square into cos nx plus summation n equal to 1 to infinity n by n square plus a square plus n square into sin nx. Right? So this is the Fourier series expansion of e power minus ax. Why we have taken 1 minus e power minus 2 pi a by pi? Because it is independent of n. Whenever you are taking a term out of the series, because the series is running over n, right, you should not take any term related to n. A square plus n square involves n, cos nx involves n. So these two remain in the inside of the series. And you can also take a, because a is independent, it is a constant, you can write a here, right? And here also n by a square plus n square sin nx involves n. 1 minus e power minus 2a pi by pi is not involving any n, and you can take it out, right? So terms related to or involving n, you should not take out of the series. So this is the Fourier series expansion of e power minus ax on the interval 0 to 2 pi, right? Now you can also try the Fourier series, finding the Fourier series of expansion of e power minus ax on the interval minus pi less than x less than pi. Instead of finding Fourier series on the interval 0 to pi, you can also find on the interval minus pi to pi, right? You try this as a homework. Now coming to the second problem, find the Fourier series of fx equal to x square in minus pi comma pi. So let us find the Fourier series of x square in the interval minus pi pi. In the previous problem, the interval was 0 comma 2 pi. Now in this one, it is minus pi to pi. Here also, the length of the interval is 2 pi. How do you find the length? When the interval is AB, the length is b minus a is the length. So here the length is 2 pi minus 0, it is 2 pi. Here also the length is pi minus pi, it is pi plus pi, 2 pi. So in both the cases, length of the interval is 2 pi. Whenever the length of the interval is 2 pi, we will proceed with the same formula for a0, an and bn, right? Now let us find a0. The Fourier series expansion formula is this. a0 is 1 by pi integral minus pi to pi, because here the interval is minus pi to pi, right? F of x dx. I am writing directly x square dx. The formula is f of x dx. Now we have the concept of even function and odd function. Suppose you have integral minus a to a f of x dx, some function, right? Then this is equal to 2 times integral 0 to a f of x dx. This can be written as 2 times integral 0 to a f of x dx if f is even function, and it is equal to 0 if f is odd function. Then what is even function and what is odd function? If f of minus x is equal to f of x, then it is a even function. If f of minus x is equal to minus f of x, it is odd function, right? Here what is f of x? X square. F of x means the integrand. Here the integrand is x square. So this is f of x here. So what is f of minus x? Minus x whole square. It is again x square, which is f of x. So f of minus x is f of x. Therefore f is a even function. That means the integrand is even. Whenever the integrand is even, we can write this as 2 times integral 0 to pi f of x dx. Here f is x square dx. So you can write minus pi to pi as 2 into integral 0 to pi. And this is 2 by pi x cube by 3 is the integration of x square. What is integral x power n dx? X power n plus 1 by n plus 1. So it is x square means x power 2 plus 1 3, x cube by 3, in between 0 to pi. When you put pi, it is pi cube by 3. When you put 0, it is 0. So pi square, 2 pi square by 3. If you simplify, you will get a 2 pi square by 3. So a0 is 2 pi square by 3. Right? Now let us find an. What is an? The formula is 1 by pi integral minus pi to pi, because the interval is minus pi to pi, f of x cos nx dx. 1 by pi integral minus pi to pi. What is f of x? Cos square, x square into cos nx dx. Again, because the integral is in the form of minus a to a, integral minus a to a, right, we have to verify whether the integrand is even or odd. What is the integrand here? Here this f is different. Let us write this as a g. The integrand is g of x equal to x square cos nx. Now we have to check by replacing x by minus x. So it is minus x whole square cos minus nx. Minus x whole square is x square, cos minus theta is cos theta, right? Because cos minus theta is cos theta, you can write cos minus nx as cos nx. So we have got again g of x. G of minus x is g of x. Therefore, g is a even function, right? So the integrand is even. The integrand is even. So you can write it as 2 times integral 0 to pi like this. X square cos nx dx. Right? Now, the most important formula that we are going to use n number of times extensively in this Fourier series concept is, we have already discussed it in the initial video, concepts video, right? So, based on that, I am directly writing this, and you can refer that formula. It is discussed in the previous video. So, whenever it is polynomial and cosine or sine, the first one is a polynomial into integration of cos nx sin nx by n, right? Plus and minus will come alternatively. Here we got plus, here minus. The derivative of polynomial is 2x. The integration of this function is minus cos nx by n square. Minus cos nx by n, and we have another n here. So, n square. Now, plus minus, and you will get a plus again. The derivative of 2x is 2. The integral of minus cos nx by n square is minus sin nx by n cube now. And in the next term, the derivative of polynomial, now the polynomial has become a constant, the derivative is 0, so you need not write. So it is from 0 to pi. 0 to pi are the limits. 2 by pi into, you remember, whenever we have two formulas, we already discussed it, right? It is sin n pi is 0 for all integers n. Sin n pi is 0 for all integers n. Cos n pi is minus 1 power n. Minus 1 power n for all integers n. So whenever we get sin n pi, we don't write it again, right? We just take 0 in place of that. So when you are substituting x equal to pi, it is pi square into sin n pi 0. Minus into minus plus 2 pi, because x equal to pi, cos n pi. So if we simplify, what you will get? 2 by pi into 2 pi cos nx by n square. Pi gets cancelled. 4 into minus 1 power n. What is cos nx? It is minus 1 power n by n square. Therefore, what is an? An is 4 into minus 1 power n by n square. This is an, where n equal to 1, 2, 3 and so on. Don't forget to write n equal to 1, 2, 3 and so on. So this is an. Now let us find bn. What is bn? Formula is 1 by pi integral minus pi to pi x square sin nx this time. Right? Again the integral is in the form of integral minus a to a. Right? So you have to check whether the integrand is even or odd. What is the integrand? It is x square sin nx. What is g of minus x? Minus x whole square sine minus nx. It is x square, but sine minus theta is minus sine theta. That is how this is minus g of x. So g of minus x is minus g of x. So that's why g is odd function. Whenever the integrand is odd, the integral value becomes 0. So this is equal to 0. You need not find out it. Since x square into sin nx is an odd function, you write it in the brackets, right? So therefore bn equal to 0 for all n equal to 1, 2, 3 and so on. So an is this, bn is this, and what is a naught? 2 pi square by 3. So therefore we can write the answer as fx equal to, what is a naught? A naught is 2 pi square by 3, right? By 2 plus summation n equal to 1 to infinity. An, what is an? 4 into minus 1 power n by n square cos nx, right? An cos nx plus bn sin nx, where bn is 0 because all bn's are 0. This series becomes 0. Therefore, what is f of x? X square equal to 2 gets cancelled, pi square by 3 plus 4 comes out, summation n equal to 1 to infinity minus 1 power n by n square cos nx is the Fourier series expansion of x square on the interval minus pi to pi, right? Now we have an application of this particular function x square on this interval minus pi to pi. We will see that. Now coming to this problem, this is very important problem, the application of this Fourier series of expansion of x square. So using Fourier series of expansion of x square, we need to prove these three formulas. Okay. So just now we have discussed the Fourier series expansion of x square as pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n by n square cos nx, right? This is the Fourier series expansion of x square, and the interval is minus pi to pi. Coming to the first one, so you need to deduce this formula from this. So how do you deduce this formula? It is in this formula you have 1 by n square, right? And in the series also you have 1 by n square, but in this series, required series, you have all positive signs, 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus and so on. Though these are all positive signs, but you have minus 1 power n. When you substitute n equal to 1, you will get negative 1 by n square. When you put n equal to 2, you will get minus 1 whole square. This becomes positive. Next term is negative, so you will get a positive and negative alternatively. We have to make it all positive terms. So for that, what to do or what to take in place of x? So this cos nx should help us by making in making every term positive. So what is cos nx? Cos n pi. Cos n pi is minus 1 power n. So if you take x equal to pi, if you take x equal to pi in the series, what happens? Pi square equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n by n square into cos n pi. What is cos n pi? Another minus 1 power n. So that this product will become minus 1 power 2n. And what is minus 1 power 2n? Minus 1 whole square whole power n. It is 1 power n 1. So pi square minus pi square by 3 equal to summation n equal to 1 to infinity 1 by n square. So this is 4 into. This is 2 pi square by 3 equal to 4 into summation n equal to 1 to infinity 1 by n square. Here 2 gets here 2 times. Therefore, the answer is n equal to 1 to infinity 1 by n square equal to, this 2 comes this side, it is pi square by 6. So hence the first one is proved. So to prove the second one, what is second one? Second one also you have all the terms 1 by 1 square, 2 square, 3 square, every term is there, but positive and negative signs are there alternatively, right? That means you should have minus 1 whole power n here to get a positive and negative signs alternatively, and this should be nullified. That means this should be vanished, like cos nx should be 1. So how to make it 1? You put x equal to 0. Put x equal to 0 in this, what happens? 0 equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 power n by n square into cos 0, 1. So 4 into summation n equal to 1 to infinity minus 1 power n by n square is minus pi square by 3. This pi square by 3 comes this side. It is minus pi square by 3. Now 4 into, you take n equal to minus 1, it is minus 1 by 1 square. You put n equal to 2, it is plus 1 by 2 square, minus 1 by 3 square, plus 1 by 4 square, minus and so on. It is minus pi square by 3. Now you can take negative sign common from this. This will become minus 4. You send minus 4 to right hand side. LHS becomes 1 by 1 square, minus 1 by 2 square, plus 1 by 3 square, minus 1 by 4 square, and so on. RHS becomes minus pi square by 3 by minus 4. It is pi square by 12. So that is also, the second one is also deduced. So how to prove the third one? The third one is 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. You have only odd number square in the denominator. You are not able to find even number square like 1 by 2 square, 1 by 4 square are not there, right? So this you can easily get it from the first two. What is the first one? From 1 we have 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus and so on equal to pi square by 6. From 2 you have 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus and so on equal to pi square by 12. If you add these two, you will get 2 by 1 square, this gets cancelled, plus 2 by 3 square plus 2 by 5 square and so on, pi square by 6 plus pi square by 12. So you take 2 common, it is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus and so on. It is pi square by 6 into 1 plus 1 by 2. It is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus and so on equal to, this is 3 by 2, pi square by 6 into 3 by 2. So pi square by 4, 4 into 2, 8. So pi square by 8, that is the required answer. And this is very, very important problem in the examination point of view for all BTech students. Right? Thank you so much. We'll meet in the next video.